This is part 2. We're going to focus on fraction addition and subtraction. Get your copy of your guided notes for part 2 in front of you before you continue with this video. So when students first are introduced to fraction addition and subtraction, we introduce addition and subtraction of unit fractions, or fractions with 1 in the numerator. And we teach students that all non-unit fractions, fractions with anything other than 1 in the numerator, can be composed of unit fractions. So for example, 3/4 can be composed from 1/4 plus 1/4 plus 1/4. Later, students learn to add and subtract fractions with like denominators. So for example, 2/4 plus 1/4 equals 3/4, or 4/4 minus 1/4 equals 3/4. When students first learn to add and subtract fractions with like denominators, they learn that when fractions have like denominators, they don't need to do anything to the denominator. They just add or subtract across numerators and keep the common denominator. And then finally, students learn to add and subtract fractions with unlike denominators. When students learn to add and subtract fractions with unlike denominators, they learn that the first step is to find or convert fractions to fractions with a common denominator. Why do we need a common denominator? The fraction, for example, 1/5 represents 1 out of 5 equal parts. In other words, the denominator 5 describes the size of each part. If two fractions, so 1/5 and 3/10, have different denominators, which they do, that means the size of each part for 1/5 is different than the size of each part for 3/10. These fractions represent different sized things. We can't add or subtract different things, so we have to find a common denominator in order to add or subtract fractions. So in this case, we found a common denominator of 10, converted 1/5 to 2/10, kept 3/10 the same, and then added across numerators and kept our common denominator constant. 5/10 can be simplified to 1/2. So if we look at this with a model, see 1/5 plus 3/10, it's hard to say what our sum is because we don't have a common denominator or a common unit. If we convert 1/5 to 2/10 and add 3/10, we can see much more easily that our sum is 5/10, which is then equivalent to 1/2. Okay, the students have often experienced a fair amount of confusion about adding and subtracting fractions and make some common computation errors. One really common error is adding across numerators and denominators and failing to find a common denominator when necessary, or failing to leave common denominators alone and just adding across. So for example, this error could look like what's happening here. 2/3 plus 1/3 equals 3/6. This student added across numerators 2 plus 1 for 3, and across denominators 3 plus 3 for 6. These two fractions have a common denominator, 3, so the denominator in the answer should be 3, but instead the student added and got an answer of 3/6. This is a really common mistake. Here are two more examples of that really common mistake. So 3/4 minus 1/3. If a student just adds straight across numerators and denominators without consideration of common denominator, the student would subtract 3 minus 1 equals 2, 4 minus 3 equals 1, for an answer of 2/1, which could simplify to 2. And here the student ignored that there are common denominators, or didn't realize that they could keep this common denominator in their answer. So they added 2 plus 1 is 3, 3 plus 3 is 6, and got a solution of 3/6, which can simplify to 1/2. In both cases, the student add or subtract across numerators and denominators either without finding a common denominator or ignoring that there is already a common denominator. This type of error can reflect poor magnitude understanding. So to understand what that means, we can look at this type of error in context. So 3/4 minus 1/3, again, just subtracting straight across numerators and denominators, gets an answer of 2/1, which could simplify to 2. Let's look at this in context. If you have 3/4 of an orange and you give 1/3 of it to a friend, what fraction of the original orange do you have left? In this case, we've answered 2. And it just doesn't seem to make sense. If I had 3/4 of an orange, I had less than one whole orange, and then I gave some of it away, how did I end up with 2 oranges? Okay, let's look at a visual model. If I have 3/4 of an orange, and then I give 1/3 of that away, what I've got left here is a fraction of 1 orange, not 2. So we know that when we subtract, we expect a difference that is smaller than the minuend, or the number that we're subtracting from. When I subtract something from 3/4, I expect a difference that's smaller than 3/4. What I've got here is a difference that's greater than 3/4. Doesn't make any sense. Accepting this answer could be an indication that I have poor fraction magnitude understanding. I don't recognize that 2/1 or 2 is a greater number than 3/4. And in effect, it doesn't make sense as the solution to this problem. Let's look at another example. In this case, again, we've just added straight across numerators and denominators without consideration of common denominator. So 2 plus 3 is 3, 3 plus 3 is 6. That simplifies to 1/2. If we look in context, we can look at it in a story and say, if you have 2/3 of a candy bar and your friend gives you 1/3 of her candy bar, what fraction of a candy bar do you have? Looks like I've got a whole candy bar now. I started with 2/3. My friend gave me another third. But my answer here is 1/2. Which doesn't match up, doesn't make sense, because I know that when we add, we expect a sum that is greater than either addend. So when I add, I should end up with a sum that's greater than either number in my problem. And I can see this is a problem already because 2/3 is greater than 1/2. When I add something to 2/3, I should get a bigger answer here. So again, coming up with this sort of answer and then accepting it could be an indication that students have poor magnitude understanding. This brings us to the idea of direction of effects. So direction of effects refers to the direction or the size of the solution to a problem in relation to the terms of the problem. For addition and subtraction, we're going to compare whole number direction of effects and fraction direction of effects. So for whole number addition, I know that the sum of 2 addends is always greater than either addend. For example, if I add 3 plus 5, I get 8. And that sum of 8 is greater than 3, my first addend, and the sum 8 is greater than 5, that second addend. 2 plus 4 is 6, the sum of 6 is greater than 2, and 6 is also greater than 4. The same direction of effects, or a sum that's larger than either addend, applies also to fraction addition and subtraction. So for example, if I've got 2/5 plus 1/5 equals 3/5. That sum of 3/5 is greater than my first addend, 2/5, and also greater than my second addend, 1/5. For subtraction, the difference of 2 numerals is always less than the minuend, or the starting number. So for example, with whole numbers here, 8 minus 5 equals 3, and my difference of 3 is less than 8 my minuend or my starting number. Another example, 6 minus 2 equals 4. My difference is 4, and it is less than the starting number, the minuend, 6. This direction of effects rule also holds for fractions. The difference of two non-zero numerals is always less than the minuend. So looking at my example here, 3/5 minus 1/5 equals 2/5. The difference, 2/5, is less than the minuend or the starting number, 3/5. All right, let's look at the direction of effects rule on the number line. So for addition, the sum of two addends is always greater than either addend. I can add 2/5 plus 1/5 for a sum of 3/5, and 3/5 is greater than 2/5, and 3/5 is also greater than 1/5. I can look at the same for subtraction. The difference of two numerals is always less than the minuend. So 3/5 minus 1/5 equals 2/5. That difference of 2/5 is going to be less than my minuend, 3/5, or my starting number, 3/5. Okay, we're going to use these direction of effects rules to estimate and determine whether our answer to a problem is reasonable. So, the addition direction of effects rule again. The sum of two addends is always greater than either addend. Look at this problem. I've got 15/24 plus 35/50 equals 45 over 100, 45 100ths. I'm going to use 1/2 as a benchmark to help me out here. So 15/24, this is a number that's greater than 1/2. Plus 35/50, this is another number that's greater than 1/2. So I've got a number that's bigger than 1/2 plus another number that's bigger than 1/2. So my answer should be greater than 1. But 45 100ths is less than 1/2. That doesn't make sense. My sum should be greater than either addend. This sum is less than either addend. These numbers are both greater than 1/2. This number is less than 1/2. So is this a reasonable answer? No. 45 100ths is not a reasonable answer. The sum should be greater than either addend, and here it's not. Okay, you're going to try this out. So you're going to use the addition direction of effects rule, which again is the sum of two addends is always greater than either addend. And you're going to apply that rule to determine if 15/40ths is a reasonable answer to 8/12 plus 7/10. Again, don't compute, estimate, and use 1/2 as a benchmark to help you out. So determine whether or not you think 15/40ths is a reasonable answer. Fill that in on number 3 on your guided notes sheet. Pause here for a second and then come back to check your answer. Okay, let's check that answer. So, is 15/40ths a reasonable answer? No, 15/40ths is not a reasonable answer. 8/12ths, this is a number that's greater than 1/2. Plus 7/10ths, this is another number that's greater than 1/2. So we've got a number bigger than 1/2 plus a number bigger than 1/2 equals 15/40ths. 15/40ths is a number that's less than 1/2. That doesn't make sense. The answer should be more than 1, right? The answer should also be greater than either of these addends, and it is not. So no, this is not a reasonable answer. The sum should be greater than either addend, but 15/40ths is less than either addend. Okay, we're going to try this out again. This time we're going to look at a subtraction problem, and our subtraction direction of effects rule says the difference of two numerals is always less than the minuend. So here's a problem. 39/40ths minus 5/10 equals 17/20. We're just trying to figure out, is this reasonable? So I'm going to use 1/2 as a benchmark and think this through. 39/40, that's almost 1. 5/10, that's equivalent to 1/2. So what I've got here is 1 minus 1/2 equals 17/20. 17/20 is close to 20/20 or 1. So I've got 1 minus 1/2 equals 1. Does this make sense? Is this reasonable? No. The difference should be less than the minuend. And these are about the same. What I've got here is 1 minus 1/2 equals 1. I should have a number that's less than 1 or less than my minuend here. So no, 15/40 is not a reasonable answer. The difference should be less than the minuend, but it's about the same. And when I think about this problem, it does not make sense. Okay, you're going to try one out. So, again, use the subtraction direction of effects rule. The difference of two numerals is always less than the minuend. So, 12/25 minus 2/50 equals 32/33. Is this reasonable? Is 32/33 less than 12/25? Use 1/2 as a benchmark to figure that out and record your answer on your guided notes sheet at number 4. Pause to do that and then come back to check your answer. Okay, here we are. We're going to check it out. 12/25 minus 2/50 equals 32/33. Is that reasonable? No, 32/33 is not a reasonable answer. 12/25 is about 1/2. 2/50 we could round or estimate that to be about 0. So I've got 1/2 take away 0 equals 32/33, a number very close to 1. 1/2 minus 0 equals 1. No, makes no sense. And 1 is greater than 1/2. But if I look at my rule, I know that my difference should be less than my minuend, and that's not what I've got here. Okay, here's our session summary. So understanding the direction of effects can help you predict solutions to computation problems, judge the reasonableness of your answers. And when you think about problems in context, the direction effects helps you to make sense of that. And then fraction addition and subtraction share the same direction of effects as whole number addition and subtraction. When you add, you end up with a sum that's greater than either addend, regardless of whether you're working with whole numbers or fractions. And when you subtract, your difference is less than your minuend or your starting number, regardless of whether you're working with whole numbers or fractions. Okay, wrap this part 2 up by filling out your self-efficacy rating. This is number 5 on your guided notes. You're going to answer this question. After this session, how confident do you feel in your knowledge about the direction of effects for fraction, addition, and subtraction?